Hi everyone. In this video, I am going to explain about the data types in Verilog programming. So data types are nothing but data types represent data storage and transmission elements found in the description of the hardware. So when you are writing a hardware description language in Verilog, we have to use data types. Okay, whether it is an integer type or float type, register, or whatever it is, we have to represent that very particularly. So data types represent data storage and transmission transmission elements found in digital hardware. Data types are divided into two types. Okay, in Verilog, the data types are divided into two types. They are, first one, nets, and the second one is registers. So Verilog supports four different values. Actually, Verilog supports four values. One is, here I will write a table, value, condition in hardware. So what is the condition for that value in the hardware terminology? So 0, nothing but it is a logic 0. It is logic 0. So false condition and 1. It is logic 1. It is nothing but true condition. X, nothing but unknown. X is nothing but unknown. So unknown condition. And the last one is Z. Z is nothing but high impedance, which is neither 0 nor 1. High impedance, or we can say it is floating. It is floating because it is in between 0 and 1. Okay, so these are the four different values we generally use in the case of Verilog, whether it is a register data type or it may be a net. Okay, so 0 means it is false condition, 1 means true condition, X means unknown condition, and Z means high impedance state. Now let us see the first type. As I said here, there are two types of data types, net data type and register data types. So first, let me explain first the net data type. Net data type in Verilog. So it represents a class of data types. It represents a class of data types such as wire, WAND, WOR, TRI, TRIAND, try or and try O, try 1. That means try 0, try 1. It represents, that means net represents physical connections between structural entities, physical connections between structural entities such as gates and any other logical circuits. So suppose if you are writing, if you are taking AND gate and its output is given to another OR gate, okay, and it is another input. When you are giving one output to other input, and here we have to specify this particular line with net. So net is an interconnection between two gates. It's a physical connection between two gates, and it does not store a value. It does not, because it does not have any memory element. It does not store a value. It does not store a value except try register net. Except this try register net, remaining all are having no memory. Okay, they don't store any number, any value. So value of net depends value of net depends on drivers such as continuous assignment or a gate, such as continuous assignment of a gate. Okay, so value of the net depends on drivers such as continuous assignment of the gate. So when you are assigning a value to the gates, as I said in the previous case, suppose if you are taking AND gate, in the AND gate we are giving the inputs x and y. Okay, this is the output sum z. So you are taking x and y, these x and y values are continuously supplied to the AND gate. Okay, then these are nets. The value of the net depends on the drivers. Then this AND gate output we are giving it to another gate like OR gate. Then this value z depends on the continuous supply of the inputs x and y. Okay, if x and y are continuously supplied, then z is there. Otherwise, if x and y are supplied at once and removed, immediately z supplies to the OR gate and it goes away. Okay, it will not store that value. Hope you understand what I am saying. Okay, whenever x and y are available, then z will be available. If x and y are continuously not available, then z will not be there. Okay, so that is the net. That is net. So net doesn't have any storage element. Just it takes the value and sends to the next one. Okay, so undriven net has a value of high impedance, nothing but z. What do you mean by, see here, if you are not having x and y inputs here, then this net here z is nothing but net. I mean z is net here. Okay, if z is not having continuous supply x and y, then z does not have any value. That value neither 0 nor 1, so it is treated as high impedance value. Okay, so all the terms what I have explained here, like wire, wand, W or try and try or try 0, try 1, all these are different interconnections used to provide physical connections between the elements. Suppose if you are taking wire, establishes a connection with no logical behavior or functionality implied. Just a wire is nothing but a wire that just carries the information. It does not have any logical behavior. Okay, and if you are taking try establishes the connection with no logical behavior or functionality implied. It is also same like your wire. And wand means a net. Wand means a net connected to the output of multiple primitives, a model hardware implementation of the wide and. So what do you mean by wand? Wand is nothing but wide and. Wand is nothing but wide and similarly var is nothing but wide or. wide or. Okay, and a triand is nothing but a net connected to the output of multiple primitives models hardware implementation of the wide and hardware implementation of the wide and. So a physical net to be three stated. So try means here three states are there. What are the three states? Logic high state, logic low state, and high impedance state. Okay, now coming to the second type, register types. Register type, second type is register type. So register variables are assigned values by procedural statements. Register variables are assigned values by procedural statements within always an initial block. Within always and initial blocks. Initial blocks. That means by seeing this line, we can understand that the previous one net type can be used for all combinational circuits. That's why we have used AND gate, OR gate, register gates. But whereas in the register type register, this register is particularly used for the memory elements. Particularly used for memory elements. That's why it is used inside the always and initial blocks. It holds values until an assignment statement changes. It holds a value until an assignment changes. Okay, suppose you are having a circuit here, a register or some circuit. The output is something like A, and this output is given to, this is circuit number 1 and this is circuit number 2. And now I am declaring A as a register. So register A. That means depending upon the inputs X and Y, some A output has come. Okay, this A is there until you are giving the next assignment for the XY. Suppose XY I have given 0 0 and I have got the A as some value 0, and this 0 will be stored inside this register A until you give the next input like 0 1. Okay, so that is the main difference between register and your wire or net. Okay, net in the net operation, just a specific fraction of seconds that value will be held by the net, and after that it disappears. It is free. Again, if any next input is there, that value will be again assigned. But whereas in the register, it is not the case. In register, that the value will be completely held by that register until you change the next input. Okay, this is the basic difference. So here, predefined register types are predefined register types are, as I said, register, integer, real, real time, and time. So these are the different types of predefined registers. Okay, we can use register, integer, real, real time, time. Okay, suppose if you are taking register, register is nothing but, so it is simply a default initial value of a particular variable. The size is nothing but a single bit. So register is nothing but a single bit information, and may never be, the register may never be an output of a predefined primitive gate. So register should not be an output. It should be an input or an in-out port of a module. I will write some details here so that you can read later. So first one, default size is a single bit, just either 1 or 0, does not corresponding directly to physical memory, does not correspond directly to physical memory. So never be may never be output of a predefined primitive gate, but it is an or in-out input or in-out port of a module or a target of continuous assignment. And coming to the second type, integer. So if you say integer supports numeric computation. Integer means numeric computation in procedural statements. It is for numeric values, numerics. It represents internally to word length of host machine, about 32 bits. So it has 32 bits of information. So initially it has to start from 0. Initially it starts from 0 and it is having a fixed word size of 32 bits. Fixed word size of 32 bits. And coming to real and real time. Real time both are variables used to store double precision, nothing but 64 bit. So I will write here. So integer size is 32 bit. Size is 32 bit. So initial value is 0. Initially it starts from 0 and it is having fixed word size like 32 bit. Negative integer is stored in 2's complement. Negative integer is stored in 2's complement. We know about 2's complement. Okay, and coming to the real. So real has a size of 64 bit. Size of double precision, nothing but 64 bit. Single precision means 34 bit, 32 bit. Here it is double precision size, nothing but 64 bit. So default size starts at 0. 0.0. 0 means 0.0 here starts because it's a real value. 0.0 specified in decimal. It's specified in decimal and exponential notation. So coming to real time stored in real numbers format, stored in real number format like your previous case 64 bit. Default value starts from 0.0. So coming to the last one, time. It supports time related computational within the procedural statements. Within the procedural statements, time related computations within the procedural statements, and stored unsigned 64 bits of information, and zero starts at 0. Okay, this is what the data types. Thank you.